Okay. Hello, everyone. Today, I, Sakha, and my partner, Sarah, we are going to present SentiMo, when our feeling can be painted and expressed using a machine. Every day, billions of WhatsApp messages, tweets on Twitter, and many posts on Facebook are released from our smartphone as we try to express our feeling and emotion. This amount of data leads us to ask ourselves a question. What if could we use a machine learning algorithm to embody our complaint, our feeling about a specific topic, such as COVID-19 pandemic? Also, how would our feeling and emotions look like if we gave an algorithm paints and brushes to draw our sentiment? My team and I are inspired to create a machine learning artist to answer these questions. We'll create this art by incorporate people feeling and emotions posted on social media, such as on a specific topic, such as COVID-19. We'll try to analyze all the text that released on social media during the lockdown, quarantine, and feed it to our SentiMo.
So basically, our model will be built based on retrieving all of these people's sentiments from social media and then inputted to a combination of two models, Clip and StyleCan2. Basically, first, to find the similarity between the retrieved text and then to convert those texts into a mosaic form of people images. And then those mosaic form will be input to Ganozaic in order to fill or construct a predefined disease-related image by those people images. So for example, if we predefine, for example, for COVID-19, a depressed nurse or a virus shape, then those two images will be filled with the generated images from text in social media. So till now, our SentiMo has a lot of noise. And as you can see, first we was able to generate those mosaic form from people's sentiments, but you can see that a lot of repetition and it's look like noisy. But we are working on that till we reach our target image.
We're facing many challenges, one of them interpretability, also the running time and the resources. We are running this model on IBEX cluster on our supercomputer at KAUST, but still it takes more than 2 days to finish the training. Also the lack of the training data. So we are working in the future to solve these problems and these challenges, as well as in next step. Currently, we are trying to interpret many arts. So we use music can model to generate a couplet based on the SARS-CoV-2 DNA sequence to make the whole picture of this piece of art. Also, we are going to work to improve our training model and data to have a very high resolution and precise image prediction. And that's our team. Thank you for your listening. And we are looking for new members. If you are interested in our project, we can reach us on Slack or our email. Thank you very much. We are happy to have all your questions. Thank you.
Thank you, girls, so much. I see Peter Kabel has already a question.
It's more a comment or a hint. I like the project and approach. I would be very careful with the terminology you are using. I mean, you know, emotions you are using, then you are, you use a model which is somehow intransparent, how it interprets a certain emotion. So there is another, you know, intransparent transparency or opaquity. And I mean, I like this the experimental approach, but I think it would be better if you try to think of how you name what you are doing. Maybe avoid such general terms like emotions, and avoid to tell people that the system you are building is basically based on real emotions. It's a real expression and things like that. Yeah, keep it a little bit more in the speculative area. I think that would be better.
Thank you. We'll take
Thank
that.
you.
So, any other comments or questions, maybe here in Hamburg or in the Zoom?
Just one thing about, so you said that your model takes 2 days to train.
Yeah.
So that's, do you need that much data to train the model? Can you train the same model with less data to speed it up a little bit?
We are trying to do this now. We are trying to use a few number of data to train the model, but the resolution was not good. So that's why we're training in big data.
Okay. That's all I had. I was just going to recommend a couple things to try to speed that up so you could do more rapid prototyping. But if you've already gone down that route, I have nothing to add.
Thank you.
All right. We would have time for anyone else. Yes, Mohammed, go ahead.
Thanks for your presentation. I wonder how you are connecting music can to DNA, the source code DNA. Can you iterate on that again?
Yes, actually that's cool. In DNA SARS-CoV-2, we have the RNA sequence of the virus. So we count each nucleotide, and then we calculate the frequency for each segment. And then we replace the noise in the model with this frequency by using ReLU method to take this. So then we generate a noise and feed it to the music CAN model to generate disco play.
Is that something that you have some initial like outputs for, or still a work in progress?
No, we have I have an output to it, but I didn't put it on the slide because it's not. Yeah, I was thinking we can make like a whole story and a booth with all the arts, but we can share it on our channel.
Yeah, thank you for sharing that. I want to thank you also and the previous team. Both of you are team of all women, so thank you for being part of the program.
Thank you.
Thank you all for your comments and questions. If there aren't any more, I guess we will continue to the next group. Thank you guys again.